Welcome to exercise 2.4. This is actually version 2.0 of the solutions of 2.4, strongly inspired by a conversation I had with Christophe, the other instructor on this course. So the old version has been deleted from YouTube now, and this is the new version, which is slightly revised and has well, just a better solution in general. So let's take a look at problem 2.4. What we want to consider is a situation where you are the happy owner of some uninsured property in the Caribbean. So how does that look? You have, well, let's just say it's a house or something in the Caribbean, and a tropical storm is approaching. And we model this by assuming that the storm can be of 3 different strengths. So the storm strength can be either 1 or 2 or 3 in severity. And we can kind of think of it as, if the higher the strength, the worse the storm is, and the more damaged your house might become. And they then tell us that the probability that the storm is of strength I is given by Pi. So with probability P1, the storm has strength 1. With probability P2, the storm has strength 2, and probability P3, with probability P3, the storm has strength 3. Now, a good way to kind of model this is, instead of writing storm strength, we can call it N or something like that, because notation-wise, it's just more efficient to write N instead of storm strength. So what we see here, essentially, is that the probability that N is equal to 1 is equal to P1, and the probability that N is equal to 2 is given by P2, and the probability that N is equal to 3 is given by P3. And also what we note is, in particular, the 3 probabilities add up to 1, and that means that, well, the sample space of N is 1, 2, and 3. So the probability that N belongs to the set 1, 2, and 3 is in total equal to 1. Now, what else do they tell us in this exercise? They say, given that the storm is of strength I, your loss will be exponentially distributed with parameter lambda I. So what this thing over here means is that your loss will be exponentially distributed with some parameter lambda I, and they let X denote the total loss. So total loss is symbolized by the letter X. And it's a random variable, so we don't know exactly what the total loss will be, but depending on what the storm strength is, the distribution of X will be different. So in the case that the storm strength is 1, X will have the distribution, the exponential distribution with parameter lambda 1. Now, this is not really a good notation here. What we actually want to write is that, conditioned on the fact that N is equal to 1, then we have that X will be exponentially distributed with parameter lambda 1. And conditioned on the fact that N is equal to 2, X will be exponentially distributed with parameter lambda 2. and conditioned on the fact that n is equal to 3, x will be exponentially distributed with parameter lambda 3. Okay, so how can we use this to solve the problem? Let's first of all take a look at what we want to solve. We want to find the density of x. So we want to find the density of x, which we will denote f subscript capital X of x. So goal, find the density of x. That's A. And then the second thing we want to do is find the expected value of x. And the third thing we want to do, well, we'll come to the third thing later. Anyways, the first part is to find the density of x. Just before we go on to the next video where we talk about the solution of A, just a quick note. It's kind of funny to think about the fact that we're so sure that x indeed has a density, because it's not just given that x is continuous. But if we think a little bit about it, it kind of makes sense, because in all three cases of storm strength 1, 2, and 3 that we can encounter, x is continuously distributed, just with different parameters. So we have this vague idea that x unconditioned, it's the unconditional loss x is continuously distributed as well, and now we want to find its density. So for that, take a look at the next video. We're gonna get started.